Hello everyone and welcome back. This is Mr. Keeney and today we're talking about 2.6 notes. So this is going to be our first step into geometric proofs. Last time we talked about algebraic proofs a little bit. Today, like I said, we're going to be talking about geometric proofs, and we're first going to discuss a proof itself, what it is. A proof is a logical argument that shows a statement is true. There are multiple kinds of proofs. The one that we're going to be working with the most is called a two-column proof, and this is something that you've also already have seen with our algebraic proofs, where we have statements and we have reasons. That is not the only way we have to format these proofs. We could have something called a paragraph proof. A paragraph proof is exactly what it sounds like. You would be writing out, almost like a written English assignment, exactly what we would do in our two columns. So instead of using statements and reasons in that graphic organizer, you would be using complete sentences, grammar, the whole shebang, and writing out a proof. There's also something called a flow proof. A flow proof is another graphic organizer where it works on taking these ideas and flowing from station to station, and we'll see examples of those in class as we move on. And the last one, which is a little bit more advanced, I would say, is called an indirect proof. Now, an indirect proof uses fancy logic. It basically says, instead of showing a statement is true, we are going to take the opposite of that statement and then show that is false. So it's indirectly proving something by showing that its negation is false. So that's a little bit of tricky stuff. We won't see much of that, but I would like to expose it to you a little bit later in this unit. Now, the parts of the proof. Here are the things that you need in a proof. And now the nice thing is that the first three are always going to be given to you. Speaking of given, you will be given information. So the parts of the proof are the given information or the given statement. You will always be given information to start with. We will never just say prove something. There will be some information provided, and then with that, you will be asked to prove something. So the prove statements, that will also be given to you. So we are giving you the starting point and the finish line. And to help you out, just because I think we're really nice, is we will always give you a diagram, which you can think of as a geometric picture. So these three things are things that are given to you that are provided for the students. If you're wondering what the heck do we got to do then, it's pretty simple. You just have to come up with the bridge from the given to the prove statement, which is the statements and the reasons. And we saw that with an algebraic proof. As we move on through the proof, we'll have to justify each step as we go. So for today on these notes, because we're going to spend a lot of time in class together on it, or talking about it if we're online, but we really want to just expose ourselves today. So I want you guys to help me justify, and then as we go through, we're going to work on doing this ourselves. So this first proof says given BC is equal to AB. Now first you'll see up here that it is already marked. I'm highlighting these tick marks here. The tick marks mean they're congruent. I'm going to try to prove that AC, the whole thing, is equal to AB plus AB. So here we go. First you'll notice I always give in or put in my given statement first. That is just what is given to me. So given goes here. The next thing I do is if I want to get to my proven statement, I'm going to say something about AC. I know that AC, which is this whole thing up here, is just equal to AB plus BC. If I take those two parts and add them together, I get the whole segment. Now this is a throwback to Unit 1. It is segment addition postulate, something that we talked in Unit 1 and used to solve more algebraic problems. Now we're using it to justify. And the reason why I'm doing this is if you take a look at what I'm trying to prove, I am almost there. AC equals AB plus AB, AC equals AB plus, and I just want to change this BC. Well, luckily I know BC is equal to AB. So I'm going to take it and substitute it in to get my final proven statement, which is how we know we are done. We have connected the beginning to the end. And what I did there was a substitution property that we learned about in our notes yesterday, and then also that we have used in the past in algebra. So there's your first example of a geometric proof. Probably the key here is being able to recall these geometric properties, geometric postulates. That will be the challenging part for you guys. So that was example 1. Example 2, I give more of the information, and so look at all the blanks on the reason side. I want to make sure that you guys are focusing on the correct thing. Number 1 says measure of AXC is equal to measure of AXD. That just comes from here. You'll notice that that is going here to our given. And I also did measure of angle 2 equals measure of angle 3. That comes down later, and so this angle 5 is also given. And then we are trying to prove, which is pretty important here, that measure of angle 1 equals measure of angle 4. So now that we have all that set up and we look at our picture, let's see what we can say. So it is telling us that AXD is equal to, they want us to use the angle addition postulate, it looks like over here. It looks like we're going to use it again. So let's take first a look at number 2, which is AXD, A to X to D. Well, that looks like, if I were to break it up here into these two smaller, it looks like 1 and 2. So I'm going to say the measure of angle 1 plus the measure of angle 2, not too bad. And let me use maybe an eraser here. And I'll use the red again. This time we're looking at AXC, so AXC, and it's using angle addition. So I see this is being broken up into 3 and 4. Awesome. And then I get really fancy here because I'm going to use AXC. AXC, you'll notice that those I've now broken up from statement number 1. I have said what AXD is equal to. It's equal to 1 plus 2, so that's nice. And I've also broken up AXC to 3 plus 4, and that's here. So really what I'm doing, which I know there's a lot of colors going on, 1 to 4, I'm just substituting in what I know. So this is a substitution. Substitution property. Then I brought in that 2 is equal to 3. So instead of putting 2 here, what I'm going to put in for 2 is 3. The measure of angle 1 plus the measure of angle 3 equals measure of angle 3 plus the measure of angle 4. And then if I were to take away the measure of angle 3 on both sides, which is subtraction, I get what I want. So you can see this is a very complicated example about what is exactly happening here, but just to show you how in-depth and kind of crazy this proof world gets, that's a good example to just kind of expose you today. I want you to be focusing on just what a proof looks like, what I will be able to do here in the future, and then we will have multiple days in class to figure out how to do these on our own. And then we have our last little bit here, which is a good place to sneak it in. A theorem, just to remind you, because I have the word theorem down there. A theorem is a statement that can be proven. And then remember our reflexive, our symmetric, and our transitive. Yesterday, I kept saying that POE meant property of equality, so property of equality. Today, we're just going to learn that it's the same exact property, but we have it working for congruency. So POC, property of congruence. So reflexive, something is equal to itself. Symmetric switches A, B, or A is equal to B, so B is equal to A, and then transitive going through the middleman. So example 3 here is name the property illustrated by each statement. For we have 5 equals 3, and then they switch it to 3 equals 5. So this would be a symmetric. Symmetric, if I could spell, I just kind of went over it. And then notice the difference today. The congruent signs, so this would be POC, property of congruence. This next one here, angle H is congruent to angle T, and angle T is congruent to angle B. You know what I like to do. I like to draw this little arrow through. I get to go through T to say that H is congruent to B. So this would be a transitive. And today, again, we see, I kind of went through them, but we can see it pop up. Congruent signs, so this would be POC. And I believe that is it. Yes, it is. So a little bit of exposure. We're getting into kind of the deep end of this unit. Please let me know if you have any questions, and I will talk to you guys later.